Hello, everyone. My name is Brian Black. I'm one of the principal architects here at Deep Instinct, and this is another web demo series where I'm going to be taking us through a competitive analysis as well as a review of the 2.3 dashboard. So to kind of start and begin this presentation, what you're looking at here is VirusTotal. This, of course, is not a Deep Instinct product. This is owned and operated by Google, but it really is kind of the world's largest public repository of malware. So I'm going to take you through my script here that I put in at the top and kind of show you the parameters under which that we've chosen this malware. So at the very top, what I have here is I've said, show me all the malware from November 15 to present. So at the time of this recording, that would be the last 3 days. And the reason I did that was because I've got some more parameters in here, like I've removed false positives. I'm looking for ransomware. But more importantly, I'm going to give an example here of what we have here is I'm saying, show me the things that right now the semantic engine cannot catch and the Tran micro engine cannot catch. So I've put these parameters in here, and you see that there are 16 samples that meet this criteria. And what you're looking at here, of course, is first submitted as of, again, the time of this recording. That would be today. So this very day, there's already samples that have come up, which these engines, these updated engines are unable to detect. But we even see some here that are about 24 hours old, and still these engines are unable to detect it. Now, I just ran this script. I don't know how the Deep Instinct engine will line up, but I can tell you this, that the artificial brain should have no problem detecting any of these samples. So I'm going to kind of spin the mouse wheel here, just kind of pick one at random. Click a download button, and this particular one was from 11/17, but you see that the artificial brain had no problem detecting it. Now, what's interesting about this is that the brain that I've decided to use for this particular example is the 109 brain. And that's really important because the 109 brain was last trained in August of 2018. I want you to think about that for a second. This is over a year old, well over a year old. In fact, we're about 15 months old or so. And that's really interesting because we never update the artificial brain. We never put out updates to the brain's model. There's no heuristic updates. There's no signature updates or cloud updates or anything like that. So this is a brain that was last trained going on almost a year and a half ago, and yet brand new samples that have been released into the wild as recently as a few hours ago or a few days ago, the brain has absolutely no problem detecting. And I'll just kind of close this one and scroll down, grab another one here. This one here is a couple days old. You see 11/16. But I want everyone to think about this for a second. This sample was updated to or sent up to VirusTotal on 11/16. That's 48 hours ago at the time of this recording. And yet these two updated engines from world-leading antivirus companies are still unable to detect it. But yet an artificial brain that has not had a single update in the past 15 months or so has had no issue detecting this. And why? Because we generally don't care about the individual sample itself. We care about the training that the brain has in identifying the bit patterns as they're attempting to write to disk. And that's what you see here. When I click on one of these again, I'll kind of actually go up to this newest guy, why not? We'll click on this one. This is only a few hours old, and yet, of course, the brain had no problem detecting it. And if you come down here, you'll see that as it begins to download, the brain pops up and says, nope, I see an issue here, and it's going to kill it. So this is really important, and what we're left with here are these partial files. And again, that's also really important because there is no raw binary left on the disk for an end user to click on or double click on or whatnot. If they were to attempt to double click on this file, it is not an exe. It wouldn't get anywhere. Windows wouldn't know what to do with it because it's leaving partial files on the asset. Now you can choose to remove those partial files with the Deep Instinct client as well. But the reason we run this test is because it's very important to validate one of our grand claims, of course, which is that we only produce a new artificial brain about once or twice a year. And again, that's a really important distinction because the number one question we get asked is, if you only release a brain once a year, maybe twice a year, then how the heck can you stop something that's, when I've got a 6-month-old brain and a brand new 0-day comes out tomorrow? Because the truth is, we don't care about the signature of that 0-day. We don't even care about the features of that 0-day. We only care, does the brain, or has the brain, had the adequate training to identify it? And of course, the famous example that we give in many of our presentations is that at some point when a person is very small, they're learning about different types of dogs. And then one magical day, a poodle walks in front of the child, and the little boy or girl will say, "Hey, that's a dog." Now that's a 0-day dog, according to that child. They've never seen that type before. But yet, because they've seen other types of dogs, they have the training to know what a dog is. Now, they may not know the word poodle, that's true, but they know what they're dealing with, even though it's a brand new dog in their world. This is the same thing. The artificial brain learns like a human does. So when it sees these 0-day events, when it sees these brand new mutations, these new types of malware, regardless of how old the brain may be, as long as it's been trained on that type of file before, of what makes it good or what makes it bad, it should be able to identify that threat, even if it's a year or a year and a half old, if the brain is a year or a year and a half old. So let's kind of take a look at what that looks like in the console. So what you're looking at here is the console for version 2.3. This is, again, at the time of this recording, the newest version for Deep Instinct. And what you see at the top here is our general dashboard information. It's showing the different types of prevented events we have in files and whatnot. And these are live buttons. I can click on any one of these, and it's going to drill into the monitoring screen, which I'll show you shortly. That will classify and start breaking these events out for you. But as I kind of scroll down on the screen a little bit, you see that we're going to have things like, high-risk devices, high-risk users. These are the devices that have been under attack significantly. Now, this is a demo environment, so a lot of these are coming under attack for testing purposes. But the two key things I like to focus on here are the top deep classifications right here in the left-hand side, and in the lower right, the top malicious file types. Starting with the classifications. This can be really important because within 20 milliseconds, the artificial brain is determining if something is good or bad. If it is bad, within 50 milliseconds, it's classifying it. And it's letting you know exactly what you're dealing with. Is it spyware? Is it ransomware? Is it a combination of the both? Is it a virus or a dropper, etc.? So it helps an organization to know exactly what they're under attack by. But the top malicious file types has significant importance to a lot of security professionals. And the reason is Deep Instinct covers a large plethora of file types, which means we're covering a large plethora of vectors. That's important because a lot of products out there, they're very, very good at PE files. And they can grab PEs, detect PEs, explode them in sandboxes, etc. The challenge is when we start stepping away from that PE vector and we start getting into things like Office files, OOXML, font files, TIFF files, PDFs, etc. When we start getting into these more obscure weaponized file types, this is where a lot of products tend to fall down. And that's not because those products are bad. It's because to make them effective, it requires, in many cases, manual feature engineering, which means you need a human being sitting down and performing feature extraction on what makes a TIFF file weaponized, what makes a doc file or a PDF or an Excel or an OXML or a OCR file or JAR file, what makes these things weaponized. And that requires a lot of money, a lot of time, a lot of resources that some companies simply have chosen not to commit to their product. Deep Instinct doesn't have that problem. Utilizing deep neural networks, we can point our neural network at a large sample set of any type of file. And within 24 to 48 hours in its training cycle, it will learn how to identify malware within that particular extension. The end result is that we don't have to have these large banks of humans sitting down and reverse engineering malware and pulling out feature extractions and all that stuff. So as a result, our base product with very little effort on our side can actually go through and learn about all these different file types, which means one of our customers is far more protected than if a customer was using another product. Simply because if they were to get attacked by a particularly crafty form of PDF ransomware, that's not very difficult to introduce into an environment. I mean, after all, in many cases, it's the human resources department's job to open up PDF files because they're looking at resumes and other types of attachments. So being able to cover all of those different vectors can be really helpful in identifying threats and making sure that they stay out of an environment. And then as I scroll all the way to the bottom, you see a threat timeline there. And this, of course, is dynamic in real time as information starts coming in. I'm going to scroll back up to the top here, and one kind of hidden screen that I've got, if I expand this, you're going to see we have a real-time event feed. This information is going to come in real time. And if you really wanted to, from here, you have the ability to do whitelisting or blacklisting, or even add an exclusion for the file type directly from this location. Of course, if you click on it, it's going to drill in and take you to the monitoring screen, which we're going to go to here in just a second. So as I click onto the monitoring screen, this is where an administrator would live if they really wanted to. And just like the dashboard, which is fully configurable, any number of those screens could have been moved around. There were other widgets we could have added. We can close any of those boxes that were on there. We also have the ability to add a number of columns to this screen, everything from event trigger information to certificate information, logged in users, etc. So like the dashboard, it can be fully modified to make sure that an administrator sees the information that they need or want to see. So as the events come in, this is where it's going to populate within the monitoring section, specifically within the events section. So I'm just going to kind of pick one of the top ones here we did. And this one's listed as spyware. And of course, as you see, we've got our deep classification right at the top. So while the primary purpose of this particular event was spyware, it did exhibit these other capabilities. And this is why the brain broke them out and listed it. But of course, at our core, we are a prevention tool. This threat was prevented pre-execution as it was being written into the environment. You see here, we're left with a CR download. This is that .partial I mentioned. Windows will list them as CR downloads, Chrome will list them as .partials, and other browsers will list them as other type of non-conclusive extension. But this is an example there of the fact that as this binary was coming down, it was terminated even before it completed its write to disk, which means there is no active binary here for someone to double click on. Windows simply wouldn't know what to do with it. Here's the hash information, which we can research on VirusTotal or Alien Vault, or simply look it up in Google. And as I scroll down, you're going to start getting some more information, such as the different events related to this hash, the process kill chain, which you can always expect to be a little quick, simply because we are a pre-execution tool. And here you see the life cycle. This is everything that was done manually or automatically to the binary. And then finally down here towards the bottom here, the events that happen on this particular device, you see we've attacked it a number of times, and information about the user that was logged in, MAC information, IP address, etc. So all of this can be gathered. Now what's interesting about this is that we've got one more option here, so I'm going to scroll to the top. We've got this gear in the upper right corner. As I click this, you have the option, again, to whitelist, blacklist, or add an exclusion from here as well. But you also have the option to upload the file to the D appliance. This is the console that you're currently looking at. If we were to do that, we would get two more options, and it would say Sandbox Analysis or Static Analysis. And while doing this, you'd have the option to send it to our internal sandbox for further analysis. Now, we do not require or use in any way the sandbox for detection or prevention. They're simply too slow. So as you see, the brain did make a decision to prevent this in real time. Zero time, actually, since it happens in sub 20 milliseconds before the binary is even written to disk. But if a person wants to have more information about what the threat was doing, again, you have the option to upload the file to the D appliance, execute it through the sandbox to determine all the little nuances of what this would have tried to do had it have been successful in landing. So the next screen we'll go to is the policy. Now you can build as many policies as you want for an environment. You see here in our test environment, we have dozens of them. But just focusing on the top, these are the ones that come default. We've got Windows, Mac, Android, Chrome, iOS. So these are the 5 policies that come default with the product. I'm just going to kind of drill into the Windows one here, and we'll walk through this one. So setting a policy is incredibly quick. Not a lot of decisions need to be made when it comes to deciding how you want the product to react. The first one is, what do we do with the artificial brain? How do we want it to behave? So I'm going to show details here. And you see under this particular scenario, we're saying we want to detect, that's the red, we would like to detect lows and moderates. We would like to prevent, however, highs and very highs. So this is the current policy. We do provide a few out of the gate that you can just kind of click on. If I move to prevent, this is what you'll see. Detect, this is what you'll see. And then of course, detect and prevent, that is what you'll see. But we've decided to go with a custom policy here that looks like this. As I scroll down a little bit, you see here dcloud services. This is a reputation service that Deep Instinct offers, and it is not required, but it is something that we say, you know what, it's an extra layer. Everything moving past the dbrain is an extra layer. So whether it's the dcloud or the behavioral analysis, which we'll cover here in a moment, or script control, all of those are just extra layers to make sure that we take multiple swings at the same pitch. So we never rely on just one engine. We have many that are constantly working to provide a full suite of protection. So we do recommend that people set the dcloud, but again, not required. Known potentially unwanted applications, it's going to do just that. It's going to say, hey, maybe this is a program you don't want in your environment. It may or may not be malicious, but it's something that maybe we feel you shouldn't have running in an environment. And of course, you have the ability to detect those, prevent them outright, or just simply allow them. Scan files accessed from network folders. This can be real handy. If you're in an environment where you do a lot of work across the network, maybe to different file shares, anytime one of them is opened across the network, the brain can scan it, even though it's not on the asset where the artificial brain is installed. Then we come down to the behavioral analysis section. You see we've got ransomware behavior, in-memory protection, which includes remote code injection and known payload execution. Again, really cool stuff, because what this is going to do is anytime a perhaps fileless attack or some type of PowerShell attack, shellcode attack attempts to take over memory space or inject itself into a good running process or take over a process, this is often the precursor to a ransomware encryption attack. So we have the ability to monitor those in real time. So while the brain does an absolutely outstanding job, 99.8% of events are handled by the brain, we do want to make sure that should a fileless attack come in, should a script attack come in, that the product can protect you from those as well. And here you see the script control. We're going to be looking for PowerShell execution, macro execution, JavaScript, ActiveScript, etc. So again, you have the ability to whitelist the good scripts, block the bad scripts, or behave in different capacities so you know exactly what's going on in your network. And then as I scroll down a bit more, we see here the automatic upgrades. This is where you get to decide if the agent updates itself automatically, and you can decide on what brain you want to use. Now, for the test that I was running earlier, we were using the 109. This particular policy is actually using the 110W, the newest brain available that we just trained and is now slowly being rolled out to our customers. You see we have the disable and uninstall passwords for your administrator to set. Windows Security Center integration. This can be key because we are certified as an AV. So as a result, if you currently have an AV that perhaps an organization isn't happy with, we can actually be the antivirus on top of course, everything else that we do. There's nothing special that goes along with that. There's not a big database involved to be an AV. We just let the artificial brain handle it. Because while our bread and butter really is those unknown threats, we're obviously trained on billions or hundreds of millions of files when it comes to known threats. So we have no problem identifying known threats, of course. So if you set that, you no longer have that little pop-up within Windows 10 that says you don't have an AV installed. We will act as that AV. And then, of course, you can decide if you want to hide the UI from an end user, or even if you want to turn that off if you're going to install it on a server. After all, no need to have pop-ups or unnecessary icons on a server. So we also have permitted connections for network isolated devices. In 2.3, we've added the ability to perform network isolation. So very similar in its EDR functions and capabilities, we do have the ability, should we want to run an investigation on an asset, or we feel that it might be compromised before we get a chance to install the agent outright or for it to perform its full scan, we can go through and isolate that. And this is where you add the connections, where you get to determine what that asset gets to communicate with. Does it only get to communicate with the console? Can it communicate out to, say, Microsoft.com if you're looking for patches? Can it communicate outbound to the web so you can search for fixes, things like that? And then finally, schedule scanning. You never actually have to set this when you install our agent for the very first time. It's going to perform a full scan of every byte on disk. So the reason we have it, of course, is that along with being HIPAA and GDPR, we are PCI certified. And being able to schedule regular scans is a component of PCI compliancy. So that is our policy. As you see, very simple to set. There's no rules to turn on or off. There's no signatures you need to enable or disable. Once the policy is set, it can just operate like that indefinitely, and you never need to set more than a few policies. Maybe you want your administrators to have a different script control policy than your general users, but by and large, most organizations simply go with just one or two policies. Before I move on, I do want to touch on the whitelist here at the top of the screen. We're going to discard those changes I did earlier. And the whitelisting is neat. You see, we do a lot of testing with this, a lot of training stuff, but we have the ability to whitelist by file, by script, by certificate, by path location, and by behavior itself. So should the brain ever make a mistake, which is a very rare event, our false positive rate is well below 1%. It's below 0.1% actually. We hover around 3 zeros and 5 zeros when we're in a real environment. What I mean by that is our false positive rate in real world customers hovers between 0.0001 and 0.000001. So an absolutely phenomenally low false positive rate. But should the brain ever make a mistake, you have the ability to override it in less than 60 seconds. The other thing I kind of want to touch on here real quick, I'm going to go into the deployment because I mentioned it earlier, so I want to show where that can be done. As I go to just any one of these assets, if I come over to the right-hand side to where the gear is, if I click on it, you see that we've got the ability to uninstall the D client, we've got the ability to download logs, and you see here, we can isolate it from the network if we want to. That's really important. This is where that is done. This lets you run a more thorough investigation, and should you choose to isolate something from the network, what will end up happening is it can only communicate based upon the rules we set on that previous page on the policy. And then as I come over to settings, here you're going to get general information such as the time limit when something becomes online or offline, where you want to send logs or how you want to send logs, such as to a syslog server, our integration with Active Directory. This is where we set up the SMTP server so that events can be emailed if that's something that's desired. And proxy settings if that's needed in an environment. And then finally, administrator contact information and the administrator screen, how you want that to be handled in terms of forcing logouts. And then finally, we've got our notifications, and then way at the bottom there, our monitoring. So we can decide if we want events that were closed by the reputation to even appear in our list or not. So this is everything that's on the left-hand side here. As you kind of click on it, it'll scroll that screen around to all the different locations. At the top here, towards the upper left, we've got our profile. You can also set the administrators. In fact, I'm going to drill into this a little bit because I do want to show these permissions on the left-hand side here. As I click on the permissions, you're going to see we do have RBAC controls. So we've got 5 different levels here: Master Administrator, SOC, Read Only, and IT Administrator. And as I click around these different things, you're going to see underneath different things are going to be green, different things are going to be red. And these are the levels that someone would or would not have access to. Moving over here towards the upper right, you see we've got our API connector. This is brand new for 2.3. This is going to allow a connector for our REST API and our ability to send information that previously we were unable to do so. This is great when we talk about orchestration with other products and other security products within a stack. We also have brand new Mdm integration here. You see native out of the box. We can set up our Mdm, and this is going to help with our mobile deployments, specifically those Android, Chrome, etc. That will allow an Mdm to take control and decide, what settings need to be there, what policies need to be there, and what should be reported on. Our audit log, of course. We're going to discard that too. Our audit log, this is everything that has happened with an environment, policy changes, sandbox reports, logins, etc. And the event notification. This is pretty cool because while we do have that API, which gives us the ability to see a lot of data, this is what can be actually seen natively. Everything from prevention and detections, behavioral analysis, artificial brain, script information, unknown sources, or USB debugging when we start talking about Android. Has something, let me scroll up here, has something been rooted or jailbroken if we're talking about iOS. Then of course our audit log, we can send all of this information as well. Whitelisting, blacklisting, anytime that's been updated. As I scroll down, if we wanted to build groups, we can get an audit log whenever they've been changed or anytime something new has been deployed. And then finally, health checks. This is the console communicating back to our backend system, which we call Web Center. And this is going to make sure that everything is healthy there and that we have good communication so that our customers can get new artificial brains when they're produced or new agent versions when they're updated and ready to be downloaded and installed. And then of course, as I come back up to the top here, the appliance backup is just that, saves those settings. And then finally, versions here way at the end. If I click on this, these are the different versions from Windows, Mac, Android, Chrome, and iOS. This is where you would come to say, download the latest version here. I'm going to click on Windows. This will download the latest version of the installer and allow a customer to install that anywhere that it's applicable, and then ultimately talk into their central console. So that's a rundown of the product itself. We saw a little bit of competitive analysis on how the artificial brain reacts and works in real time against real malware. I had no idea what those samples are, but even though the brain's about 15 months old, we certainly trust that because it's been trained so well, it can identify brand new threats. And then of course we saw the console itself and how an administrator would go through and actually utilize the console to get the information that they need. That will end this particular training session, and there will be more to come. Thank you.